Okay, so this is the video for balancing equations. This is a lot easier to see being done in person versus looking at it at a presentation. So hopefully this helps out. So we're going to start off. So this is balancing equations. So we're just going to start off writing that up in the topic. So balancing equations. Okay, so the first thing we need to talk about is the law of conservation of mass. So law of conservation of mass. Okay, so basically that says is mass is neither created nor destroyed in a chemical reaction. So mass is neither created nor destroyed in a chemical reaction. So basically what you had in the beginning better be what you have in the end. You can't just make things disappear, and they can't just appear out of anywhere. So basically total mass needs to stay the same. So, but what can happen is that atoms can rearrange. Okay, so atoms can rearrange, so we're not creating or destroying anything, but they just kind of get shifted around. So there's steps in balancing. So we're going to do our next section is balancing. As you can tell, I'm making this video up at school. So number one is you're going to write the unbalanced equation. Now, in some of your worksheets, we already give them to you, but in case you didn't, when you start predicting, you'll actually have to start writing your own. So you're going to write the unbalanced equation. And make sure we do not forget about our diatomics. Remember, those are the ones that cannot be by themselves. So remember the name Brinkelhoff. So B-R-I-N-C-L-H-O-N-F. Remember, those cannot be by themselves. They have to be in pairs. So it'd be like Br2, I2, N2. Step 2 is you're going to count the atoms on each side. And we're going to do practice here in just a second. Count atoms on each side. 3, we're going to balance by adding coefficients to the front. Okay, so we're going to balance by adding coefficients. Coefficients is just a fancy name for number. In front of the compound. Oops, let me fix that. Okay, now it's important to know that you cannot add numbers to the middle of a compound, so I'm going to put that in red. So it's hard kind of writing on this iPad. So cannot add numbers to middle of the formula. So you cannot add numbers to the middle of the formula. So an example of that would be, let me use a different color for that one. So if I had something like H2O and I needed 2 of them, I would put a 2 in front. Okay. If I needed something like this, so say I needed 2 oxygens, that's why I put 2 in front. What I'm not going to do is this. I'm not going to throw a 2 in the middle of this and then now I've just got this mess. Okay, so this would be the wrong way. This would be the right way. You can only add numbers to the front. Okay, and you cannot change subscripts. I'm going to switch my colors on that one again. So we cannot change subscripts. Okay, what I mean by that is if I have something like H2O, okay, and I need 4 hydrogens, I'm going to put a 2 in front of it. That's all I can do. I'm not going to do this. I can't do H4O. Okay, you can't actually alter the compound. You can only add numbers to the front. And then lastly, we want to save, if we can, save oxygen for last. So I'm going to go back to red. This will just help you in the long run, so save oxygen for last. Okay, this will just make things a lot easier for you. Okay, then step 4, so let's go back to my other color. So step 4 is we're going to reduce coefficients if possible. Okay, so if I had something like this, like 2a plus 4b, and then I had 2ab. Okay, if I could reduce that, I would. Okay, so this would just be like a plus 2b equals ab. Okay, so if you see something you can reduce, that means you can do that. Just makes things more simple in yourself. Okay, then number 5, the last thing, and this is important, you want to keep polyatomics together. Okay, if you try to break those up, it will make this more of a nightmare than you realize. So you want to keep those together if possible. But, I'm going to put this in red, they have to be on both sides. So they have to be on both sides. And what I mean by that is if I had like my arrow, and if I had nitrate on this side, and I had nitrate on this side, I'm not going to break that up into nitrogen and oxygens and try to balance those individually. I'm just going to keep it as nitrate on both sides. So I have one nitrate over here, one nitrate over here. That'll make things infinitely more easier for you. Okay, so now what we can actually do is we can actually try some examples. So this is a lot easier like when you actually see it. Okay, so let me switch colors. Okay, so let's look at our example. I'm going to do NaClO3 gives me NaCl and O2. Okay, so this is my unbalanced equation. Okay, so we're going to figure out how much we have. So the best way to do this is I am going to write down what I need to balance right below the arrow. So I have NAs that I need to balance, I have chlorines that I need to balance, and I have oxygens that I need to balance. So again, I'm saving oxygen for last. Now what we're going to do is we're just going to count how many we have on each side. So on the left side I have 1 Na, I have 1 chlorine, and I have 3 oxygens. So again, I just counted, I have 1 Na here, I have 1 chlorine here, and I have 3 oxygens here. Okay, so that's all I did there. Now on the right side, I've got 1 Na, 1 Cl, and then 2 oxygens on the right. Okay, so if I look, I need to start balancing. So I'm going to start from the top. I'm going to look at Na and work my way down. So Na is good, 1 and 1. Chlorine's good, 1 and 1. Oxygens is where I'm having a problem. Okay, so if I have a 3 and a 2, okay, I know 2 and 3 can't go in each other, but what's the closest number that can be divided by both? Well, that would be 6. So if I multiply this NaClO3 by 2, that will fix that oxygen. So now I have 6 over here. But whenever you put a number in front of the whole thing, it will affect every atom that's in there. So now instead of 1 chlorine, I have 2. And now instead of 1 sodium, I have 2. So my whole left side has changed. Okay, now there's nothing wrong with that. Now we can just look at our right side and see what we can do. Now oxygens were at 6 now, so on the right side I need 6. So I'm just going to do is I'm going to put a 3 in front of this O2. So 3 times 2 gives me 6. And now I'm going to go back and fix my NaCl's. So I have 2 NAs on the left, 2 Cl's on the left, and I need 2 on the right. So I'm just going to put a big 2 in front of this NaCl. And that will fix my Na to 2 and fix my Cl to 2. Oops, let me fix that. So again, this 2 distributes across. So if you put a number in front of it, it's going to affect everything. And that's the only place where you can put numbers. It has to be in the front. You cannot actually alter the actual compound itself. So that would be your answer. So my correct ratio would be just a 2, 2, 3. Okay, all I did was write down the numbers I put in front of each compound. So that was my answer. So now my formula is actually balanced. So let's do another example. Okay, let's say I've got Na plus H2O and that gives me NaOH and H2. Okay, I'm going to go ahead and draw my lines in front of the compound, so that's where I'm going to put my balancing numbers, my coefficients. Okay, and now what we're going to do is we're going to simply write down what we have to balance. So I've got Na. I'm going to put it down here to give myself some space this time. I've got Na, I've got H, and I've got O. Okay, so let's take a look. Now, this is one thing you can do if you would like to. You can switch H to H2O to HOH if you want to. So like it would basically just look like this. So that's one way you could, that way you could just do H and OH. You could keep OH as a polyatomic. It's kind of up to you on that one. So we'll kind of see how it works and see if we need to do that. So let's kind of go back. We'll just try the Na and H and O and see if that works. So I've got on the left, I've got one Na, I've got two hydrogens and one oxygen. So again, we're saving oxygen for last. I've got one Na on the right, I've got three hydrogens on the right. Okay, and I've got one oxygen. Okay, so let's look. So my NAs are good. Now my hydrogens, I have a 2 on the left, and then I have a 3 on the right. But this is where it kind of gets a little bit tricky because you have a hydrogen right here, and you have a hydrogen right here. So there's two places you can alter things to kind of make it work. Okay, now ultimately I'd like to get to 6, but realistically it's kind of hard to do it that way. So let's actually try the HOH trick. So what we're going to do is we're going to clear this up for a sec. So I'm just kind of showing you now this way. The way we were just doing is usually works just fine, but I'm just showing you both ways on how you can do this. So what I'm going to do is I'm going to take this H2O and I'm going to switch this to HOH. Okay, so I'm going to treat H like its own, and I'm going to treat OH like a polyatomic. So now I'm going to count and see what I have now. I still have one Na, one H, and one OH. Now on the right side, I have one Na, one OH, and two H's. So now let's see if we can fix it this way. So my NAs are good. Now I'm going to move on to my hydrogens. I have 2 on the right, 1 on the left. So that means I'm going to put a 2 in front of this HOH. Now that fixes my H, but it also changes my OHs to 2 now. So again, if you put this here, you have to change this as you go. So that's why I altered H is now 2 and OH is now 2 as well. So my H's are good. Now let's check my OHs. So I have 2 on the left, 1 on the right. So I'm going to put a 2 in front of this NaOH to fix this OH. So this becomes a 2. But this also affects my Na, so now my Na is at 2. So let's see if we can go back and fix our Na. So I have 2 on the right, 1 on the left. So I'm going to put a 2 in front of here. And now that makes 2. Now I'm all even. Everything's nice and pretty. Okay, so my answer would be a 2, 2, 2. And if you don't see anything right there in front of the H2, that's a 1, just imaginary 1. So that was my correct ratio right there. Okay, so that was the purpose of that was to show you if the H and O doesn't work, you can switch H2O into HOH. All right, let's do another example. Let's say I have Na3PO4 plus ZnSO4. I know that doesn't really look like a Z. It's kind of hard to write on this tablet. Okay, then I have Na2SO4 plus Zn3PO42. Okay, I know that looks really complicated and there's a lot of stuff there, but this is what I mean by keeping polyatomics together. It'll make your life so much easier if we do that. So I'm going to look, I have sodiums, so I'm going to worry about sodiums. Now if I have PO4, that's phosphate, and I have PO4 on the right side too, so I'm going to keep that as PO4. I am not going to break that up into pieces. Then I have zincs. Zincs are by themselves, so I'm going to do zinc. And then sulfates, I have SO4 on the left, I have SO4 on the right, so I'm going to keep that as SO4. Okay, so again, do not break those up. It'll make things a lot more complicated. So if I look on the left, I have 3 sodiums and 1 phosphate. I have 1 zinc and 1 sulfate. On the right side, I've got 2 sodiums, 1 sulfate, 3 zincs, and 2 phosphates. Okay, so I'm going to start at the top. So again, it does not really matter which way you go. I usually start at the top. The biggest thing is just keeping oxygen. If oxygen was by itself, keeping that at last. Okay, so I'm going to look at sodiums. So I've got 3 sodiums on the left, 2 sodiums on the right. So the closest number that we can divide it by both is 6. So what I'm going to do is I'm actually going to change colors, so maybe that might help you see a little more. What I'm going to do is I'm going to put a 2 in front of this to get me to 6. So now this becomes 6. But this also affects my phosphate now. Now my phosphate's at 2. Okay, so all I did was distribute across. Now I'm going to fix my sodiums on the right. So I have 2 on the right, but I need 6. So I'm going to put a 3 in front of this Na2SO4. So this is going to distribute. So now I have 6 NAs, and I have 3 sulfates. So my NAs are good, my phosphates are good, but now my zincs and sulfates are off. I have 3 on the right, okay, and then I have 3 zincs on the right, and I have 1 zinc on the left. So what I'm going to do is I'm going to put a 3 in front of this zinc SO4. So that fixes my zincs, but it also actually fixes my SO4s. So 3 times that 1 gives me 3. Now all my numbers match, so that means I am done. So my answer would be 2, 3, 3, and there was nothing here. We didn't have to do anything with that one, so that's just a 1. Okay, so again, make sure to keep polyatomics together. Don't split them up, otherwise that will be a major pain to try to balance that out. Okay, and then just honestly just stick with one thing at a time and just work on it. It's almost like a kind of a puzzle. Okay, so now let's go to another one. We'll do one more. Now this is one that gets a lot of students. This is where you can run into a possible decimal. It's not really that difficult, but I want to make sure I go over this one. So let me go back to my color. Okay, I'm going to give myself some room here. So what we're going to do is we're going to do C7, H6, O2, plus O2 gives me CO2 and H2O. So hopefully you can look at this and tell me this is combustion because you get the same products every time. Okay, and I'm going to go ahead and write my little lines in front to tell what numbers I need to do, what coefficients I need to put there. So again, I always save oxygen for last, so I always do this the same way I do CHO every single time. Okay, so I'm going to look on the left and look on the right. So I have 7 carbons on the left, and I have 6 hydrogens on the right. 6 hydrogens on the left, and I have 4 oxygens on the left. So now don't forget there is an oxygens here, and there are oxygens here. Okay, so just don't forget that. Now, I'm going to look at the right side. I have 1 carbon on the right. I have 2 hydrogens on the right, and I have 3 oxygens on the right. Okay, so let's start with carbon. So I have 7 on the left, and I have 1 on the right. Now, one thing I do want to say is this right here, the last thing I want to do is put any numbers in front of that, because if you do, it's going to switch your whole left side. If you can, but we're going to save that for last resort. So if I have 7 carbons on the left and 1 carbon on the right, I'm going to put a 7, and I can go ahead and do that in a different color so you can see that. I'm going to put a 7 here, so that fixes my carbons to 7. But now my oxygens, so 7 times 2 gives me 14, but do not forget about this oxygen over here. A lot of students do. They forget this is even there, so I actually have 15 oxygens. Okay, now I'm going to work on hydrogens. I have 6 on the left, 2 on the right. So I'm going to put a 3 in front of this to make this 6. But now that affects my oxygens again. Okay, so I still have 14 right here. And now 3 times 1 gives me 3. So 14 plus 3 gives me 17. So now I have 17 oxygens to worry about. Okay, so again, the last thing I want to do is touch that one. Okay, because if you do, you're going to switch the whole left side up, which is going to switch the right side up, and you're basically starting over from scratch. So I'm going to figure out what can I do to this oxygen here to make it to 17. So I know this 2 right here, this O2 on this C7H6O2 cannot be touched. So 2 plus what gives me 17? Well, 15 would give me that. So how can I get O2 to 17? Okay, what you can do is take 15 divided by 2, and that gives me 7.5. Okay, but at this point you're wondering because you're seeing a decimal and we cannot have a decimal, but this is the decimal trick. So go ahead and write 7.5 down, and then what can we do to actually fix that and make it a whole number? Well, what you can do is just multiply it by 2. So if you multiply this by 2, this becomes 15. Now, just like in everything we've been doing, what we've talked about is if you do this to 1, you have to do that to them all. Okay, so what I'm going to do is I'm going to clear some of this stuff up real quick. Let me make some room. Okay, just to kind of clear the clutter there. So what I did is I wrote down 7.5 and I doubled it. This is called the doubling trick. Okay, but I had to double everything now. If you double that one, you have to double everything. So if I had a 1 here, imaginary 1, because I hadn't touched it, this now becomes a 2. Now if I have a 7 here, this becomes 14. And if there's a 3, this becomes a 6. So let's check and see if this is correct. Okay, so 2 times 7 gives me 14 carbons. 2 times 6 gives me 12 hydrogens. Now 2 times 2 gives me 4 oxygens, but don't forget about the 30 that are right there next to it right here. So that gives me 34 oxygens. Now on the right side, let's look. So 14 times 1 carbon gives me 14. 14 times 2 oxygens gives me 28. But don't forget about the 6 over here on the H2O. Okay, so 28 plus 6 gives me 34. And then 6 times 2 hydrogens gives me 12. So if you look, my numbers are perfectly matching now. So my answer would have been 2, 15, 14, and 6. Okay, so that was the notes for balancing, and I'll do more on the actual worksheet, but hopefully that kind of helped out.